Hello, this is Mrs. Groves. Today we're going to be continuing with Chapter 7, and we're going to have two activities that we're going to be doing today. We are going to cover a worksheet called 7.5a Practice Special Cases. And what I'd like you to do is call these notes and put them in the notes section of your binder. And then when we're completed doing these practice problems, then you're going to get the rest of the period to work on book homework. So please have your pencils, your rulers, if you need a calculator, and we're going to do special cases. And we want to put these in notes. So we're going to solve the systems by graphing. You need to always show your work putting equations into y equals mx plus b. And it's very important that you draw your lines very clearly so you can find where your lines intersect. So this one we're going to call line 1. And that's 4x minus y equals negative 4. And we're going to call this one line 2, which is 4x minus y equals 2. And we're going to put them into y equals mx plus b. Y equals mx plus b. And you know how to do this. So you can go ahead and put them in y equals mx plus b, or you can watch me do it. So for line 1, we subtract 4x from both sides. We get negative y equals negative 4x minus 4. We divide by negative 1 because we have to isolate the y. And we get y equals 4x plus 4x plus 4. So here, the slope is going to be 4 over 1, and the y-intercept is going to be 4. So we're going to put our y-intercept at 4, and we can't go up and over, so we're going to go down 4, 1, 2, 3, 4, over 1, down 4, 1, 2, 3, 4, over 1. And we are going to draw our line. So that's line 1. Now we're going to graph line 2. We're going to subtract 4x from both sides. We get negative y equals negative 4x plus 2. Divide by negative 1. And you get y equals 4x minus 2. And something should be clicking from the notes that you took last class about what's going to happen with these lines. Here, the slope is 4 over 1. The y-intercept is -2. We plot the y-intercept at -2. We go up 1, 2, 3, 4 over 1. Down 1, 2, 3, 4 over 1. And voila. You should notice that we had the same slope. The y-intercepts are different. So our answer is no solution. That is one of our special cases. Now we're going to go do problem number 2. Again, we're going to take and we're going to put our lines in y equals mx plus b. So our first one is -x plus y equals 1. This is really an easy one. Think to yourself, what do I do to isolate y? I add x to both sides, and I get y equals x plus 1. Here, the slope is going to be 1 over 1. The y-intercept is 1. So we graph the y-intercept. Okay, that's the point on the y-axis at 1. And the slope up 1 over 1, up 1 over 1. And you want your lines to be very straight. So I always put lots of extra points to make sure that they're going to be straight. So there's line 1. Line 2 is -2y plus 2 plus 2x equals 0. Now we want to get y by itself. Now we could do two things, or we can do one step at a time. So however you're most comfortable solving for y, I'm going to subtract 2 from both sides. I'm going to get -2y plus 2x equals -2. Now I'm going to subtract 2x from both sides. We get -2y equals -2x minus 2. And we got to get y by itself, so we divide everything by -2. And we get y equals x plus 2. Aha! You should be noticing something. Okay. The slope here is 1 over 1. The y-intercept is, and I made a mistake here. Hopefully you caught it. Because -2 divided by -2 is 1. My bad. So now you can definitely see something that's going on here. Okay. And again, I made another little mistake. This isn't 1/2. What is the slope? Oh, you didn't even see it. The slope is 1 over 1. The y-intercept's 1. And if I were to graph it, which I don't need to, okay, the y-intercept's at 1. Okay, so both of these lines have the same y-intercept. And I would go up 1 over 1. And just for demonstration purposes, we see that we have the same y-intercepts, the same slope. Okay. So we notice the equations are the same. And since the equations are the same, make this a little bit smaller so you can see everything. The equations are the same, so the lines, this is infinite solutions. And that means that every point on this line is a solution. So that's our second special case. Our third problem is kind of a special case because students kind of have a hard time realizing horizontal and vertical lines. X equals a number. That is a vertical line, and it has an x-intercept of 4. So the x-intercept is 4, and all of the x-coordinates are going to be 4. So we have this vertical line, and now we're going to graph the other line, and you should be noticing that this is a horizontal line, and this horizontal line has a y-intercept of 2. And so here is our y-intercept. And just as a review, we can rewrite this equation. So it's y equals 0, x plus 2. Right? Because 0 times x is 0, so that would cancel out, so we get our y equals 2. And we know that when our slope is 0, our line is flat. Okay, we have this horizontal line. So now, what's the solution? The solution is where they intersect. The point of intersection is at 4, 2. We could check this. We check the first equation. Our x is 4, so 4 equals 4. It checks in the first equation. Now, we're going to check the second equation. Our y is 2. So 2 equals 2. It checks. So now what I'd like you to do is spend about the next 10 minutes going through and doing the problems on the back by yourselves. Right. And what I'll do is I will do these problems. Okay. And the sound effects that you're hearing in the back is my wonderful dog Ozzy chewing on a bone. At some point I'm going to try to figure out how to have this time when I'm doing these problems silently put some music on for you. But I'm learning how to do this. So I'm going to go through and I'm doing the problems. And I'm not going to be talking at all. If you have trouble with these concepts, then you can watch me. And what I really would like you to do is do them on your own. So now Ozzy and I are going to work on these problems while you're doing them at your seats. And when you graph these, just to make sure that you can graph them using any method that you want. I'm going to try to do a little bit of both, graphing them with x and y intercepts and graphing them with y equals mx plus b. In this case, if you were to put this into y equals mx plus b, you should get y equals x plus 4. So you could do it either way. I'm going to do it with x and y intercepts. And don't forget, you always want to check your solutions in both original equations. So my problem number 4, my solution's checked. I bet you're doing these faster than I am. I think I might just speed this up a little bit and challenge you. I just want to make a note that sometimes when you're doing these problems and use the x and y intercepts, it's sometimes hard because we're using our pencils to get that to connect with the other line. And so putting it in y equals mx plus b, like in this case, was much easier because I have the y-intercept here. I use slope, go up 2 over 1, up 2 over 1, up 2 over 1, and bang, I hit the line. So that makes me very happy because the solution here is, hopefully, when I check it, is going to be -3, 4. And I'm going to check in both equations. So hopefully you're done with number 5. I'm on to number 6 and 7, and both of these I'm going to put into y equals mx plus b. So for number 6, you should be seeing that the solution here is we have parallel lines. They do not intersect. So there is no solution. So there is number 6. Off to number 7. I'm going to put both equations into slope-intercept. So number 7, they're the same line. So that means you have infinite solutions. So I hope you're enjoying these videos. And that's it. And you'll get the rest of the period to work on your homework. Have a good day. From Mrs. Groves and her dear buddy, Ozzy.